Okay, so returning to our primary aim, which is to look at discrete outcomes, we want to see whether two binary outcomes are related. Let's start with that. For example, here's an example. Let me introduce this topic with an example. So consider whether electronic fetal monitoring, let's call it EFM, has an impact on cesarean sections, whether to have a cesarean section or not. So what they did in this study is they looked at 5,824 deliveries. Of these, roughly half, 2,850, the women were subjected to EFM, and the other half, roughly 2,974, were not. Now let's see what happened to these 5,824 deliveries as far as C-sections were concerned. So 358 of the 2,850, so of those who were EFM exposed, 358 had a C-section, and of these who were not exposed to EFM, 229 had a C-section. So, as you've seen before, this is just two binomial situations. Those who were EFM exposed and those who were not. And then the question was, what is the probability of having a C-section? So it's a binomial situation. So we've got two binomials, but with n is exceptionally huge. So what to do about this? Well, what I'm going to be talking about is the very popular Chisquare test. And you may have heard about this because it's really ubiquitous. Now, how does this Chisquare test work? Well, exactly like all our hypothesis testing works. Namely, you start off with the if. If the null hypothesis is true, if there's no difference between those who were EFM exposed and those who were not, that's our null hypothesis, what do we expect to see? Then, what did we see? And then compare the two. Compare what we saw to what we expected to see. So what do you expect to see and what have we seen? And so we'll have to come up with a statistic that compares these two differences and then consider how this statistic varies from sample to sample to sample. So the same approach as we've always taken in this. So for example, let's go back to our numbers and we display them in our little 2x2 table. So there's the little 2x2 table, and you've seen a number of these now. So there's the 2x2 table, and the column tells us whether the woman had EFM exposure or not. And the row tells us whether she had a C-section or not. And this is what we are going to test. We are going to test whether the C-section rate, as we go down, whether the C-section rate here is the same as the C-section rate there. So whether the C-section rate is impacted by the EFM exposure. So another way of looking at it is the row classification dependent or independent of the column classification? The column classification, whether you're in this column or that column, depends upon the EFM exposure. The row classification, whether you're in this row or this row, depends upon the cesarean delivery. So here is our null hypothesis. That's our null hypothesis. We say that the C-section rate is unaffected by EFM exposure. Now, if that is true, then we can ignore the column classification and just go with the totals. So we can say, okay, what is the CFM exposure? Well, we've got 587 out of the 5,824, so roughly 10%. So this is how we're going to be arguing that if we ignore the EFM exposure, this is roughly 10%. 587 over 580. So we expect that same 10% of these. We expect that this should be 10% of those. And of those, this should be 10%. That's the way we're going to proceed. So, for example, when we go and we get Stata to do these calculations for us, we can ask Stata, show us the frequency, that's just like the last slide, but also show me the row percentages and what the second entry in each cell is the row percentage. So, for example, 52.42% of the no C-section did not have EFM. 40%, 47% did have. So, but that has to, because that has to add up to 100. Of those who did have a C-section, 39% did not have EFM exposure, 61% did, for a total of 100. So overall, there was 51% had EFM exposure, 48.94. This is roughly, should be 50-50 by design. But look at this. Amongst those who did not have a C-section, there was a much higher percentage here than here. Or another way of saying that is, amongst those who did not have a C-section, only 48% had were under EFM, and of those, so this looks suspiciously big. Of those who did have a C-section, 61% of them were EFM. Or we could argue column-wise. Look at the column percentages. So now 92.3% of those who are in this column, this is the no EFM column, 92% of them did not have a C-section, whereas 7% of them did. In contrast to those who did have EFM, 87% did not have a C-section, but 12.56 did. So is this difference here between 12.56 and 7.70, is that something we can attribute to chance, or is that too far away from the null hypothesis that we would worry about it? Another way of looking at this is, if you use your tab plot command, is to draw a bar graph for the cell counts. Now, this is with the option percentage EFM. That means that we condition on EFM. So it's like the row percentage. So these should sum up to 100%. And it looks like possibly this is a little bit thicker than that, which would mean that this is a little bit higher here. It's a little bit higher than this one. We could have taken the percentages instead of the column percentages, we could have taken the row percentages by putting C-sec in there. And that's exactly what we did on the next slide. So there it is with C-sec. So now this is given C-section. So for example, for those with a C-section, what percentage had EFM? And that's this one. And what percentage did not? That's this one. And look at that. Those who did not have a C-section, this is the no EFM and this is the yes EFM. So it looks like this here is much bigger. It looks like this one is much bigger than that one. And then of course this one has to be smaller. So what this is saying is, if you're in the yes C-section, yes EFM, this one here, this bar looks bigger than it should be. So even though this one is bigger than that, we've got that this one is smaller than that. And so that's telling us that there's some sort of pattern here. And the question is that significant or not? So let's just play with the numbers instead of the bar graphs. And so from the totals, we can estimate what is the probability of a C-section. Remember we said that's a roughly 10%. So that means the probability of no C-section is 0.899. So let's apply this probability of a C-section to each of the two groups, those who had the EFM and those who did not. So what do we expect to see if EFM has no effect? Well, then we'd expect that of the EFM exposed mothers, all 2,850 of them, roughly 10% should have a C-section. So we expect 0.101 times the 2850, so that's 287. So we expect that 287 of these mothers would have had a C-section. And that means that roughly 90% of them, 2850, which gives us 2563, would have had a vaginal delivery. This is if the 10% held for these mothers, the EFM exposed. And this 10% we got from everybody, which was ignoring the EFM exposure. Okay, so that's the way we proceed. Let's do the same thing now for the mothers who were not EFM exposed. So of these 2,974, roughly 10% of them, which comes out to be 300, we expect that 300 of them had C-sections, and the other 2,674 had vaginal deliveries. Let's compare what we expect to what we actually saw. So we just said we expected 300 of them, and we saw 229. So what's in the boxes here are the results of the calculations from the previous slide. Okay, we expected 300 there. That left 2674 here. We expected 287 there, and that left 2563 here. Compare those to what you actually observed. So compare the 300 to the 229. It looks like there were a few more than in the expected than we actually saw. So in the no, we came up short. Whereas in the yes, we've come up much bigger than expected. We expected 287 and we're seeing 358. So the question is, sure, if we went off and tried this on another 5,824 deliveries, we're going to get, even if we had the same number here and the same number here, we're going to get some numbers different. These are going to be slightly different next time we do this. So we do expect some variability every time we repeat this. But the question is, how about, is this too much? If this is this difference too big, or can we just attribute it to chance? Now, before we answer that question, note we could have worked the other way. We could have worked on the rows instead of the columns and gotten the same results. So for example, we could say, okay, what percentage or what proportion had EFM? And the answer is 2850 divided by 5824, which is roughly 50%. What percentage had no EFM? Roughly 50%, really 51.1%. And so now we can apply those numbers to the mothers who had C-sections, say 587 of them, and if we apply the 4.489, we see that 287, we expect that 287 had an EFM, roughly 50-50. And of the other mothers, those who didn't have C-section, of the vaginal deliveries, there were 5,237 of them, then we would expect that roughly half of them, 2563, would have had EFM. If there's no relationship between C-sections and exposure to EFM, if there's no relationship between the row and column classifications, then this is what we expect to see. And we see that these numbers are exactly the same as we had before. So there they are. They're exactly the same. So in the square boxes, this is what we'd expect to see if there's no relationship between EFM exposure and C-section. All it is looking at this ratio here, or I'm sorry, this proportion, 587 to 537, which is roughly 10%. And then we take this and distribute it roughly 10% up here and 90% down here. And then do the same thing for this guy. 10% up here and 90% up here. Or if you want to work on rows, then you take this and put roughly 50% of it there and 50% of it there. And look at this, and roughly 50% there and 50% there. So this is what we would expect to see, the square boxes, if there is no relationship between EFM exposure, which gives us the column classification, and C-section, which gives us the row classification.